Hi all. It's been a while since I've made a video. I've been pretty busy working on Selectrix and Mavis. Selectrix is a compile time static type checking system for Elixir. Most of the work right now is going into Mavis and an inference engine built on Mavis called MavisInference. And Mavis is a type library that'll be able to help do the type checking for Selectrix. Here are some of the links for them. I'll also put them below the video so you can click through to them. The past week or so, I've been working mostly on building handlers for the different opcodes. What that means is that after you've compiled your module, but just before Elixir has, sends off the, hey, I'm done doing this module, Selectrix will intercept the compiled binary, disassemble it into Erlang bytecodes, and analyze the code and try and figure out what types are flowing through your code, right? And then it'll stop you if you're making a mistake. So this is compile time static type checking. So I've been working a lot with opcodes and compiling, disassembling, and looking at and gazing at Erlang bytecode, which is a lot of fun. But for the past few days, I've kind of been more working on Mavis, which is the type library, backporting some things that I really want that I've come up while I'm trying to build the code for the type checking. And interestingly, I kind of have discovered that there's a new type for the beam. So hopefully you guys will find this interesting. If you take nothing else away from it, here are the key takeaways. And I'll refer back to these to kind of reinforce this knowledge. But type signatures in the beam are a statement of safety, and I'll explain what that means in a few moments. The way that Dialyzer does function types is a bit broken. In particular, they need a top type per arity. Dialyzer could probably stand to do a little bit more work than it's actually doing. We'll kind of explore these topics in the next few minutes. All right, so let's go to my playground here, and let's talk about what it means for a function to be typed, right? So in Elixir and Erlang, we have this tool Dialyzer, and one of the cool things is that VS Code, if you use VS Code, automatically will try to run Dialyzer on your stuff and figure out what the type specs for your function should be. And in fact, you can even click on these and turn these suggestions into reality. That's amazing. The VS Code team is doing a really fantastic job. So this is a really simple function called neg, and what neg does is it takes a number and then it takes a negative of that number. And so obviously it's okay for you to pass it a number, but what happens if I don't pass it something that's not a number, so that's not in this in this type? Well, let's do it, right? So let's spin up a IX console. And so we'll do playground. So checks out, everything's fine there. I can pass it a floating point number, which is also part of number, and it'll also output a floating point number. But what if I do something that's like this? It's like an atom. I'm gonna crash, right? And if I do something like a PID, I'll still crash. Great. So what this type spec is kind of it's a statement of safety, right? It says that I guarantee that I can be passed a number, and I will also output a number, but I guarantee that if I'm given a value that falls into this type, I won't crash. Okay, right? And in particular, I think it's also important to note that as Elixir is a functional programming language, we have these lambdas, and I can generate a lambda, and spec looks kind of like this, where I give it this is what I mean to say a one arity function that takes number and outputs number, right? So likewise, I can do lambda equals playground.neg lambda, right? And I got this lambda value. Now I can do lambda.1 works fine. Lambda dot negative 4.7 works fine. But if I give it foo, it'll crash. Same deal, right? If I give it self, it'll crash. So this is just a fancy way of saying it's a lambda that has this type signature. Okay. So far so good. So we have an understanding that, once again, type signatures in the beam are a statement of safety. Okay, so where's this broken? So let me give you an example of something that's kind of not quite right. And so I'm going to copy paste this code. And so this is just going to be a silly function that is a guard. It's got this is function guard. And so that should restrict the inputs, and it knows that tests can accept lambdas, right? So let's make this type spec real, right? And however, it's accepting this type of function that's any. And what that means is that it should only accept functions that are okay with outputting or with taking an input of anything. So neg lambda does not qualify for that, because if you give it something outside of number, which can be an any, right? So like any, that's like could be an atom, it could be a PID, right? Neg lambda does not satisfy this criterion. So in theory, we shouldn't be able to pass neg lambda to playground. So like let's recompile. So playground test lambda. But I mean, of course that works, right? I mean, is function is pretty promiscuous. It will take any one arity function and output true if it's a one arity function. So basically what I'm saying is this type spec is wrong. This any is not right. So I mean, by way of comparison, what's like a real function that's any, right? So let me show you a real function that's any. And so io.inspect, right, takes any value and just spits it out. So if I recompile, right, and then I do insp equals playground insp lambda, right? Now insp will take foo just fine, and it'll also take a PID with no problems, right? And of course, if I do playground test insp, well, that's really going to work. I mean, and it should. But my point being is that like the fact that this function can take neg lambda, which is a member of a much more restrictive set than any, or much more broad set, excuse me, than any. Because note that insp, if I had a spec of number, right? Well, if I had a spec of number any, insp would be able to like satisfy the requirements in the parameters. So there's something weird about this. It's not the right spec. Okay, so I mean, right, for now this seems like really academic. Like what's the point? Like who cares, right? So let me show you still a slightly more contrived scenario, but it kind of like reflects the sorts of situations that you can get into where Dialyzer will not be able to help you because it can't do these functions correctly, right? So, all right, so let's take a look at these functions. Def funky, this is just a weird funky function that I wrote, but it will demonstrate the problem, right? So, obviously, like, first for starters, this funky function should only output a number, right? Because it needs to output a number in order to successfully conduct this addition. So like for starters, Dialyzer is not correctly identifying the output type of the function. That's a problem. But like, I mean, I feel like there should maybe be something else here, because we know that A has got to be a number. So, it should also be able to, at least say, hey, you got to be able to take a number instead of any. This is maybe overly restrictive. It could be numbered. It should be number. And in practice, like, so, here's where it becomes a problem. If I pass neg as this lambda, right, or the lambda for neg as this lambda in funky, that's going to work. And if I pass weird, which is this weird function that takes atoms and outputs binaries for some reason, well, that's not going to work, right? Because what's going to happen when I pass it to funky is that if I pass a number, we're going to have a problem because atom to string won't accept a number. If I pass an atom, it's going to have a problem because you can't add an atom to anything. Okay, so a priori, this thing should not be good, right? And let's recompile. And so let's do playground.failure 1. It's going to crash because weird can't take a number. And conversely, well, we can give weird an atom. So if I give it an atom, well, now our problem is that plus can't take an atom over here. So this function is doomed to failure. It should, well, in an ideal world, it should stop compilation and say, hey, you got a problem. But nothing's happening. I'm not seeing any VS Code warnings. I mean, if you don't trust that VS Code is doing the right thing, right? We can even do mix compile and mix dialyzer. And Dialyzer is perfectly happy, right? It says done, passed successfully with green color. Everything's okay. You don't have any bad code. Okay, so I mean, this is, and just to prove that my dialyzer isn't broken or anything, right? We can do def x or function, or let's not call it function. Let's call it func x, and then do x plus no good. Right, so immediately I get this yellow line. Dialyzer, VS Code knows that Dialyzer is complaining. It gives none as the output type, which means that you've done something horribly wrong. And Dialyzer will, sure enough, it'll complain. It says, look, this function call will not succeed. Yet it can't really do these lambdas very well. And that's a problem because Erlang's a functional programming language. Functions are supposed to be first-class citizens or whatever. And in particular, it's really dangerous for Elixir practitioners because we use lambdas all over the place in prominent places like enum. Enum uses lambdas nobody's business. Okay, so going back to this, we've seen the way that Dialyzer does function types is a little bit broken, and I think kind of in the end, let's take a look at what the solution for this is, and it's going to have something to do with this with this function that I had before, right? So what is the type of this function? That's the question that we want to answer. What should this have been, and what can we get if we make something like that a reality? Okay, so let's go back into Elixir. And I've got the Mavis library set up, so let's import type, and let's import type use type.operators. So just as a warning, type.operators will overload the in operator. So you'll see usage of in to mean subtype of, which is non-standard. It's just to make understanding this easier. So for example, 1 in 1 to 10, true, but also 1 in built-in integer, true, and 1 to 10 in built-in integer. But -5 to 5 in built-in pause integer, not true. Okay, so that kind of just gives you a little bit of a level set understanding of what I've overloaded in to do. And so let's talk about the relationship between different functions here. So I'm gonna create one of the macros that I've built is a macro called function, which makes it easy to like output, or easy to input functions, right? So that might be a little bit confusing to you, but let's do this. Let's io.inspect intfn struct false. So you can see that this is actually a structured data type, and this kind of weird yellow glowing console output is really just overloading the inspect protocol. It makes it look like a type spec, which is exactly what it's supposed to do. So this represents a lambda of integers that takes an integer and returns an integer. And so one of the other ones that we looked at was the any function, right? And so that's that. So let's look at this, int fn in any fn. Oops. Should learn how to type. So it's important to note that this int function in the Mavis type system is not a subtype of any fn. And the reason why it's not a subtype of any fn is because this is actually a more restrictive requirement, right? Even if I do this, right? Built-in integer, so let's match the output types. We'll call this any int. So int fn in any int. That's not true. But interestingly, any int is in int fn. Right? Because any function that can take any value will also safely be able to take an integer. So it's kind of interesting that the relationship of subtypes is inverted for the parameters of a function. So, in Elixir and Erlang, we have this other type that we could use, right? And so this is something called allFn, right? And allFn is, it has triple dot in the Dialyzer typespecs that Elixir lets you build, right? And that means that it takes any arity. But, this is kind of bad because we've lost arity information, and in this guard, in particular, we're looking at functions that have to be arity 1, and it would be nice to not lose that information somehow, right? I think this is a really interesting type because look, so int fn is in all fn. It is a subtype because any function that matches this integer is going to match this sort of wildcard parameters. Okay, so what we need is something in between this and somehow expresses the fact that there's no restrictions because in fact this built-in anything here that's showing up, that's kind of in fact the opposite. It's saying that it needs to be very very stringent because it needs to not crash on any term, right? And that this is allowed to crash on some terms. It's less stringent than this. Okay, so I've created this type that I call the top type, right? And so here's kind of my proposed Dialyzer spec for it, and it's an underscore. I think from a set theoretical perspective, it would have been okay to use built the none function. But there's something kind of wrong about that as well. It just doesn't have the right connotation. What I'm saying is that I don't care about what the parameters are. It just needs to fit a certain arity. So likewise, I've got also one where you can do 2, right? Let's call this 2. So that's a 2 arity top function. But here's the key point. So int fn, is it in top fn? Yes. And is any fn in top fn? Yes. So this is the correct type, in my opinion. This is the correct type for is function x1. And if I do is function x2, right, then this would be this top fn2. That's what Dialyzer should give you. Okay, so yeah, so like to sum things up, functions need this top type to handle like these generic is function stuff. And moreover, beyond that, Dialyzer should be doing a little bit more legwork and figuring out that this is not okay. This failure function should really have like red flags all over it. And even better if you could hook it into the Elixir compiler. But so hopefully, since I'm thinking about these things pretty heavily, when it comes time to release Selectrix and Mavis, they'll come with support for all these wonderful things that you didn't know you wanted to keep your programs from crashing. All right. Take care, everyone. Progress is going pretty well. It's just still like a very sloggy phase of writing this code, but I'm pretty optimistic.